Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. On the part that we see in our screen, we'll demonstrate the use of SolidCAM's 2.5D milling to machine the part, and we'll be doing this in one setup. Let's take a look at the operations that we've used to machine the part. Our first operation that we used was a face mill operation to clear off the excess material that's on top from the stock to the actual target itself. If we go into the operation, we can see that we have our geometry as shown over here, and if we go in and show it, you can see the actual boundary around the part where it has to be machined. The tool that we'll be using will be a 40mm face mill, and the levels is set at the upper level of 0.5 millimeters, which is the amount of excess material that we have above the part. Now let's go into our technology field. In our technology, we'll be working in a hatch fashion where it'll be going back and forth over the part itself, as the tool is not wide enough to finish it in one pass. In addition to this, if we go into the parameters of the hatch, you'll see that the corners, as we get to the edges over here, we'll be working using a fillet. If we take a quick look at the simulation, the tool will go down, go across the part, and as you can see, as it goes between one pass to the next, it does a fillet movement as to avoid any kind of sharp movements on the machine until it gets to the very end. Now in the next operation, we'll be doing a outside contour cut to cut out all the material that's on the outside of the part. So if we go into our profile operation, you'll see that we have our geometry, which is around the outside of the part. The tool that we'll be using will be a 16mm end mill. And if we go into our technology, you'll see that we'll be leaving a wall offset of 0.3 millimeters and having a 5mm step down, which will be in this particular case a total of 3 down steps. In addition, we'll be doing one pass around to finish the part. Let's take a look at the simulation, and you'll see that the tool will go down on first pass, second pass, and then the third pass, and then do one pass to finish off the outside contour. Now the next operations will be dealing with pocket operations. The first one dealing with this area over here, having this as an open pocket on these sides over here, plus this area as an island. Whereas the second pocket will be dealing with this area where all the sides are open and these two nubs are a pocket. And the third one dealing with this area inside over here as a regular through pocket. If we take a look at the first operation, for example, you'll see that our geometry has the outside chain as shown over here, where these are marked as open, and the second chain is the actual island. In this particular case, we'll be using a 16mm end mill. And if we go into our technology and go into the open pocket tab, we'll see that we'll be using a profile strategy to machine out that surface. Taking a quick look at the simulation, you'll see that the tool will be working around on the part itself using a profile strategy to clear off the entire area. A pocket operation with a profile strategy to machine out the part and working around the island over here. The same was done for this pocket over here, as shown in the tool path on the top of the part. And if we go into our next operation, you'll see that we'll be working on this inside area over there, inside that through pocket. This time, however, we'll be using a 10 millimeter end mill. In our technology, since this is a regular closed pocket, we'll just be doing a contour of that pocket. Taking a look at the simulation, you'll see that it does a contour operation inside over here, clearing out the inside pocket through the part itself. Also, if we take a look again at the simulation, you'll see that the tool pass that we have is going down with a helical ramping into the material. Now, in the next two operations, we would like to clear out these smaller corners over here, these areas around here, since the previous tool that worked over there was not able to get into the corners because the tool was too large. So if we take a look at the first one of those operations, you'll see that we'll be using the exact same geometry we used in the pocket operation to clear this out. And we'll be using a smaller end mill, a 3 millimeter end mill. So if we go into our technology area, we've used the option of rest. Now in rest material, we've used separate areas, and we've also told it what was the previous diameter being used in that area. So therefore, it will only work in the areas where the 10 millimeter end mill was not able to clean out. If we just take a look at the simulation, you'll see that the tool pass will only clear out in this area. And if we take a look at the next one as well, you'll see that this one worked in these areas around here as well. Now, in the next operation, I'd like to work on the chamfers that we have on top of these studs. So if I were to go into my profile operation, you can see that the geometry are those edges on top over there. And the tool that I will be using will be a 8 millimeter chamfer drill with a 90-degree angle. In my levels, I've told it that I wanted to do a profile depth of 1 millimeter, as that is the actual size of that particular chamfer. If I go into my technology, we've used the option of chamfer. Now with chamfer, what I told it to do is to use the 2 millimeter diameter of that tool to create that chamfer. If we take a look at our simulation, and we'll do this using Solid Verify, you'll see that the tool will go down, create the chamfer on those edges, as well as on the stud in front of us to complete the part. In our next operation, I'd like to machine out this slot using a T-slot. So we use the T-slot operation, and if I were to go into the operation, you'll see that my geometry in this particular case is the wall line over here. The end mill that I will be using will be a slot mill with a 36 millimeter diameter and a cutting length of 3 millimeters. My levels will have the ceiling at -2, which is this area over here, whereas the depth will be this floor over here. Now let's go into our technology. In our technology area, we'll be doing a finish cut on the ceiling, wall, and floor, and we'll have an overlap between the passes of 1 millimeter. As far as cutting, we'll start from the middle of the slot, work our way down, and then work our way up. Let's take a look at the simulation, and you'll see that the tool will go in to the middle, keep on going down, and now start working up to the top of the part, completing that slotted area. Now, the rest of the operations are all drilling operations. The first set of operations are spot drills to spot all of the different holes that are on the part itself with all the different sizes. And the rest of the operations are also drilling operations with a separate tool for each one of those with the proper size drill needed to drill out those holes. Now, if we take a look at the simulation on the entire part, you'll see that we first do the face mill operation, then the profile on the outside, then the first pocket with the open sides with this area as an island. The next area is this open pocket area with the two studs. The through pocket, finishing out the corners of those areas as well, putting on the chamfers and working on the T-slot, then doing the spot drills as well as all the drills to finish up the part. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for our Professor tab. Take care and have a nice day.